and it took us ages to think of the title. So CAP 3 is, to use its official Sunday name, a dose non-inferiority randomised trial, or randomised control trial. So what that means is we want to know whether the dose we know that works is 2 tablets a day. And we want some people to take 2 tablets a day, we want other people to take 1 tablet a day, and other people to take a baby quarter tablet. And then we follow those 3 groups. So everybody gets aspirin, but they vary in their dose. And so we've now got 26 sites around Britain. That's all the genetic centres plus the Royal Marsden. And this is my spludgy graph, as I call it to Jill. She gave me another spludgy graph, but I discovered she didn't know where Birmingham was, so I thought I'd better use this one. It's not in Wales. Right?
And the water comes from Wales.
So they just drink Wales's water. So the big spludges are the ones that are now open. And Jackie has recruited 45 people in Newcastle. We've got 4 in Aberdeen, we've got 7 at St Mark's with the second team open. We've got 5 in Nottingham, 3 in Sheffield. So we're up and running, and we're hoping, obviously, Birmingham will be a major contributor because it's got a very well organised cancer genetics team, and they're all wonderful, and I'm saying nice things about them, so they'll try really hard to recruit for the study. So what we hope to do is get 1,500 recruits in the UK, and meanwhile we're talking to Sweden, Finland, Denmark, Germany and other countries to see if they can recruit as well and get this going so we can get up to 3,000 gene carriers, which would give us real power to tell whether these 3 doses make a difference or not. Now it'll take us 5 years to answer the question, but the good news is everybody's getting aspirin anyway, and we think everybody should be taking aspirin if they've got Lynch syndrome, unless there's a powerful reason not to, because those benefits clearly outweigh the side effects of aspirin in this population. These are the people, so if you're not from here, in fact Emma, somebody said something to her and she's gone to Manchester apparently, so she's not staying in Birmingham, but there will be someone else taking over soon. But these are all the people who will be looking after it in the different centres. And the colour codes are the ones that are open. I apologise, you might say, why the hell is it taking so long? Well, because we've got rules now. We've got to personally come and visit and tell people how to switch their computer on and all that sort of stuff. And so Jill is taking teams around the country, and I'm at some of them, she goes to them all, to get them up and running so that we're all fulfilling the regulations. So we have a website you can tap onto, www.cap3.org, and there's lots of information on there that will give you more information if you want it. Now, this is Jill's slide, which she finds enormously amusing for some reason. If you want to do prevention trials, you have to start at a very young age, because this was taken in 1990 and it's finished. So I'm hoping God's going to let me live another 25 years to finish this one. No, but basically, when we did CAP 2, life was so much easier because we didn't have the European Clinical Trials Directive telling us how to do clinical trials more effectively across Europe, so we just did it. And we recruited in every country in Europe, and we had 5 people in Newcastle running it. We just sent the aspirin in a packet, and everyone was happy. Apart from the customs people in St Paulo, who were dubious about little packets of white pills and white powder in plastic sachets that held it there long enough that they didn't end up joining the trial. But anyway, so we've got problems now. There's much more strict regulation of clinical trials, with good reason, because things have gone wrong in trials. But to be honest, they've rather overdone it. So we've got massive regulatory barriers, like all this monitoring stuff that we've got. And we just heard today, for example, that MHRA are in conversation with the pharmacist in Birmingham about whether it's acceptable to post aspirin out to people rather than send it special delivery. Because apparently once someone got some drugs sent to them and it went to the wrong address and their neighbour opened it and they're suing the hospital. Therefore, for the now you can't send stuff by post. So basically, if your neighbour found out you've got a supply of aspirin, wouldn't that be the end of the world? I don't IRAS has got better. When we first started doing these trials in the 1980s, we had 16 ethics committees in the northeast, and I used to have to get every one of them to agree to everything. So at least now we have one port of call. That's good. But the National Institute of Health Research, which we are the leads for at the moment, is great because that funds staff in every centre. So that's a big step forward. But the big push back is this Clinical Trials Directive. So one of the things it insists on is that you have to procure your aspirin packaging from a sort of blinded process. It took 2 years to find somebody to put the aspirin in the packets, and it's costing us so far £835,000 to put our free aspirin in packets. Okay, so each of those boxes you get costs about £100 in order to comply with clinical trials legislation. And I keep saying, actually I say something with an extra word in there, but I'm not allowed. So this is Nick, who was number 1 in our trial, and he's a furniture maker in Newcastle. And he will be in one of these 3 blinded limbs. We're only treating for 2 years because we couldn't afford any more boxes. But after 2 years, we're hoping to give everyone just free, standard, low-dose aspirin, which is kind of what people will gravitate towards. Hopefully that will be sufficient. But if worse comes to worse, it might be not as good as a bigger dose, but we'll get onto that in a short space of time. So we'll follow people for up to 5 years after they've stopped taking the randomised dose to see what happens. And the primary output is how many new mismatch repair deficient cancers or Lynch syndrome cancers do we see at 5 years in those 3 groups, and say whether people in the little dose get the same number of cancers as the people on the big dose. It's a bit boring, I know, but it's absolutely essential. The only way we can actually get the world to give patients aspirin is to answer this question. Because one of the reasons is every doctor thinks they know that aspirin's really dangerous, and it isn't. But it's got a sort of bad reputation, which I'll come back to. This is what the boxes look like. They're supposed to go through a letterbox. They do go through a letterbox, that's why you haven't got one of those silly ones. And inside there are half a dozen, in fact 7 of these 28-day packs. And they fold up, but I've just been told they don't fit in handbags as well as they might. But anyway, they do fold into a little book, and you take 3 tablets a day, 2 in the morning, 1 at night. The 2 with the little sun on are when you take in the morning, and the little moon is what you take at night. Hopefully that will be self-explanatory. And you just basically take as many as you can remember until the end. So that's another way of looking at it. It's a bit confusing to the experts, but I hope sensible people can see that it's logical, that there are dummy tablets in these packets. Everybody gets some aspirin. So you'll get 3 tablets a day, and either you'll get 2 big real ones and a little dummy, or 1 little dummy real one and 2 big, you know, I mean basically you've got a combo of those 3 versions to give you the 3 doses. So the 2 live on the left, 2 dummies on the left and 1 live gives you 100 milligrams, 2 big live and 1 dummy on the right gives you 600 milligrams. Unfortunately, they keep getting called placebo tablets. So people think they're on placebo, but you're not. Nobody's on placebo. Everybody gets aspirin. They just get different quantities. Now, why is it so hard to get people to take aspirin? Well, I chaired an international webinar thing of cardiologists last summer. And this was some of the results we got. 800 cardiologists were asked some questions in their medical training. And one of the questions was, does aspirin prevent cancer? This was, remember, 2014. And so if you look there along the bottom, 7.3% said that aspirin has no effect on reducing colorectal cancer. 11.3% said it was net harm compared to the risk of bleeding. 48% thought it was a modest effect, and 33% got it right. So 2/3 of experts got it wrong. They actually underestimated or completely ignored the fact that aspirin prevents cancer. In a funny sort of way, it's almost disadvantageous that the cardiologists got there first. You know, they think they own aspirin, they know everything about aspirin. And the fact is, aspirin sort of slipped off their radar a bit because there are now other drugs they can use to stop your platelets sticking together. So they say, oh no, we don't use aspirin anymore, we use clopidogrel or whatever. But the fact is, they don't do bowel cancer, so they just spend their lives fixing people's heart attacks. And we all live in our little boxes. So there is a widespread lack of understanding of the benefits of aspirin in terms of cancer prevention. And I should say that the statistics are showing that it's preventing other cancers, gastric cancer, esophageal cancer, probably reduces breast cancer. So it isn't just Lynch syndrome, remember, it's all cancer that this effect is seen. The other thing to say is that people overestimate the risks of aspirin. And this graph looks rather scary, but I'll just explain it to you. So this is excess bleeding events, and this is where people have actually died because they had a gastrointestinal bleed and they were taking aspirin. So people have died. It's rare, and in fact, when you go back to look at the statistics, nearly all of them are very old people. I say that cautiously because I'm now nearly a very old people too. But basically, it's when you can see there from 60 to up to 64, it's extreme. So that's 0.1 per 1,000 there. Okay, so that's about 1 in 10,000 people taking aspirin could have a bleed that killed them, which is scary. But I'll come back and still remember that you know, coming to this meeting carries a probably 1 in 10,000 risk of being run over. You know, so 1 in 10,000 is a very small risk. But when you get older and more frail, that risk starts to rise, so that the frail elderly, it's about 1 in 1,000, will have fatal complications from taking aspirin. Having said that, when you're frail elderly, most things carry fatal complications. And I can tell you, they're bowling in my alley too now. You know, so I mean, we understand that. So basically, people in the old, very elderly range do take aspirin, but they do, in fact, probably get left on it longer than they should. So a lot of my colleagues in gastroenterology and cardiology, the people they see are the 87-year-olds coming in with a major bleed who are taking aspirin, saying, bloody aspirin, you know, when in fact they should have stopped their aspirin 10 years ago. But of course what we're doing is giving aspirin to the young fit population, and in the young fit population these side effects are dramatically less. So even that 1 in 10,000 is still mostly looking at people in their 50s and 60s, and when you get into in a genuinely sort of asymptomatic population, the risk is less than that. So going back to CAP 2, these were the numbers from CAP 2. We had 11 significant gastric effects in the aspirin and 9 in the placebo. We had 2 major cerebral events, people having strokes basically, in the aspirin group, and 3 in the placebo. We had 1 heart attack in the aspirin group and 5 in the placebo. So these are small numbers, you can't draw statistics from that, but that's kind of what you'd expect. So if you're taking aspirin, you're slightly less likely to have a thrombotic stroke, you're slightly less likely to have a heart attack, you're slightly more likely to have a significant bleed. But they're very, very small risks. And actually these risks are slightly less than the risks of colonoscopy. So just to put it in context, you are as likely to get a big major bleed and die having a colonoscopy as you are taking aspirin. I don't want to put you off taking colonoscopies, because colonoscopies are actually very, very safe. But the point is, if you do anything to people long enough, you'll get the odd one that goes wrong. So I think my colleagues have sort of got the balance wrong. They'll do a colonoscopy while having their tea. You know, I mean, oh yeah, I'll have a colonoscopy, no problem. But take aspirin, they'll spend 20 minutes trying to talk you out of it, because they've all been told aspirin's really dangerous. And I'm labouring the point because you're going to have to talk them down. You know, your doctor's bound, somebody's going to go and see their GP and say, oh, bloody hell, aspirin, that's really dangerous. So it isn't. The other thing, the reason that people have major cerebral hemorrhages is because of high blood pressure. Aspirin doesn't make you have a cerebral hemorrhage, but if you pop a blood vessel into your head because you've got high blood pressure and an aneurysm, having aspirin on board isn't good because it stops it blocking off. So basically, what you don't want to have is high blood pressure if you're taking aspirin. And this was a very big study done which showed that, I think on the next slide, that this is a bit complicated, but basically these were people with high blood pressure. What they showed was that giving low dose aspirin to people who had their blood pressure controlled, there was no excess of major strokes in those two populations. So it's about having high blood pressure probably that makes that major risk. The other thing is that some of you will have H. pylori. This is a chronic gut infection that is, particularly in the older population, it's less common now. And most people have minor symptoms from it or none at all, but the GP can do either a stool test or a blood test to exclude this. It's not necessary, but it's a good idea if you're going to take aspirin regularly, and we put it in our information to GPs, to ask if you can have an H. pylori test and just rule out this infection in your gut. Because if we carry these bugs in your stomach, then your risk of an ulcer is significantly higher, and all you have to do is take antibiotics for a couple of weeks to clear it. It's very treatable, but most people don't know they've got it, and therefore don't get it treated. In fact, you should get it cleared anyway, because it statistically increases the risk of gastric cancer. And since Lynch syndrome is associated with gastric cancer, there's an argument for all people with Lynch syndrome to be checked for H. pylori. So it's a good excuse to get it done.
How often should you be checked for it?
Probably only once. I mean, most people have carried it for years. Once you've got shot of it, unless you happen to be you're Japanese and you decide to do what... In Japan it was traditional for grannies to chew the baby's food for them, which is a bit off-putting if you're not Japanese. So basically they used to give all their babies H. pylori by chewing the food apparently. But anyway, so it was very, very common in Japan. It's very rare now in our young population. It mostly came from people not having fridges. So when I was a kid, not everybody had a fridge, so we used to use a lot of pickled foods and all that sort of stuff. I sound really old now, don't I? But I mean, everybody's got fridges now. You know, we don't live on foods sort of stored in jars and things in the pantry. And so H. pylori has declined progressively over the years. But I mean, there's nothing to stop you having it. It's a very simple test if you want to have it done. If you get any indigestion, get it done. So here's some frequently asked questions. Is it a high dose? Well, not really. When I was a lad, aspirin was about the only tablet we had for anti-inflammatory and painkillers, and we started at 3 a day and built up to 10 a day. So in fact you could take 3 grams of aspirin a day, and we used to stop when people used to get ringing in their ears. So I wouldn't recommend you do that. But the point is that 3 a day is the baseline. It's called the analgesic dose. So we chose 600 milligrams or 2 aspirins a day as basically a high sub-analgesic dose. So in a funny sort of way, it's actually a low dose in traditional medicine. But of course, because a little tiny amount stops your platelets sticking together, we've now got into our heads that low dose is a quarter aspirin. So it's not me. Side effects. I'll tell you that.
Minicab.
Is someone Uncle
I'm not
Cat?
doing anything.
It's a minicab.
Connect. Talk to
Maybe
him.
my phone talking. Is that my... Alright, fine. Side effects from scopes are about the same. So I think that's the take-home message. There are some risks of taking part in this trial, but there are risks in all things in life, and I think the benefits of aspirin clearly need to be set against those side effects in the case of Lynch syndrome. Yes, we need to do this because the Americans and the Germans have just had national studies, and they said we're not yet ready to recommend aspirin for Lynch syndrome, which is ridiculously conservative, but that's the situation we live in, because there's this negative vibe about aspirin, and it is a very cheap and effective intervention. Why do we need so many people? Because it's harder to prove a difference between different doses than proving a difference between some and nothing. So that's sort of just a statistical problem. Can you join after cancer? Yes. Can you join without a diagnosis? No. What about ulcers, H. pylori, cerebral hemorrhage? If you've got high blood pressure, get it treated. The other thing we're going to look at is some blood samples. So we know that aspirin gets metabolized in different ways in different people. And this is just one of my PhD students made this. So these are all enzymes that, like UGT186, breaks down aspirin. Some people are good at it, some people are bad at it. And whether or not you're good at it or bad will affect how effective aspirin is for you. So in the future we can personalise people's aspirin dose. It may be that some people need more than others. And this study will actually look at that to see what the benefits are. How does it work? So it's probably not to do with stopping platelets, although that might stop cancer from spreading. It might affect cancer spreading, because spreading cancer cells are covered in platelets. They stick to them. And some thought is that it might protect them from the immune system, and therefore if the platelets don't stick, it's easier to kill the cells when they spread. Having said that, metastasis is very rare, because one of the effects of Lynch syndrome is that it makes the cells not able to express their tissue type. So when they start to try and move away from their original site, they get spotted by the immune system and more easily killed, which is why the actual outlook is much, much better in Lynch syndrome compared to other types of cancer. So for ovarian cancer, for example, we've got a study that Ian and I just involved in, and these were people who were discovered to have ovarian cancer while on surveillance. Their survival rate was 94%, and that's dramatically higher than what the textbooks will tell you for people with ovarian cancer normally. So the good news is the immune system seems pretty good at containing these cancers and gives you time to get them out. Most bowel cancers have an upregulation of an enzyme called COX-2, which is part of the inflammatory process. And that graph I showed you at the beginning means all people who take anti-inflammatories like naproxen and ibuprofen seem to have less bowel cancer. So there looks like there's some sort of general anti-inflammatory effect that's cutting cancer risk. And that's not entirely unreasonable when you think that, in a sense, cancer looks a bit like an inflammation. It looks like a chronic inflammation when you look at it down the microscope. So it may be there's some generic effect of an anti-inflammatory. And that's why the bigger doses of aspirin might be having a bigger effect, because they're acting as an anti-inflammatory and not just stopping your platelets sticking together. The other thing we're just writing a paper on now, we've looked through the CAP2 study, we looked at what are called mucosal biopsies. And the aspirin was affecting the T cells in the lining of the bowel. These are the immune cells that help attack cancers. So aspirin actually has a direct effect on changing your immune response. And that maybe also explains why the cancers are more easily attacked. The final one there is the pro-apoptotic effect. So basically in plants, aspirin is made to help plants kill dodgy cells. They kind of kill off the part of the plant that's got an infection. And salicylates are produced for that reason. So basically, in our natural diet as wandering herdsmen, we would have had huge amounts of salicylate from naturally occurring sources when we ate natural plants. The stuff you buy in Aldi or Tesco or whatever contains no salicylate because it's all grown in greenhouses. There is no infection to drive up the salicylate levels. So two things there. One is we've lost salicylate from our diet, and secondly, small amounts of it might be good for programmed cell death, which is exactly what you'd want for preventing cancer. Because what we think might be happening is you're killing the cells that will become cancer 3 years down the line when they start to behave abnormally. But it also will vary from person to person, as I've already shown you. Final thing to say, sorry I've gone on a bit, microsatellites. So these are these bits of repetitive DNA that are hard to copy, and you need your DNA repair system to put them right. Now, some of those are inside genes, and this is a slide from our partner in Heidelberg who's doing this work. So Magnus has been analysing for years what are called frame shift peptides. This is a gene called TGF-beta receptor 2. It's involved in cancer in the general world, and in the middle of it there are 10 letter A's in a row. So if your mismatch repair system's out, if both bouncers have gone to the loo and you've lost your mismatch repair in a cell, and you go from 10 to 9, you can't fix it, so it sticks. Now if you move one letter out of the chain on the top, you change the amino acids. Remember those 3-letter reads I told you at the start? So if you take one letter out of a story made up of 3-letter words, everything moves back one. So you now get a different set of 3 letters and a different set of amino acids. Goodbye, goodbye. So what we've got here are the normal string of amino acids represented by single letters, and then below there you switch to so the R is an arginine, so you switch to arginine if you move backwards and go back. Another one you switch to valine. So you've got the wrong set of amino acids, and you come to a premature full stop. Now these don't work. These proteins are the wrong string of amino acids, but they still leak out of the cell, and the immune system sees them and says, what the hell's this? It's not one of ours. Has anybody seen this before? It's not one of ours. No, zap it. Okay, so basically they zap things they don't recognise. And so if you look at people who've got mismatch repair deficient cancers, they've got antibodies against these peptides. Okay? But the interesting thing is that what the team in Heidelberg found was when they looked at people with Lynch syndrome, even if they haven't had a cancer that they know of, they have the antibodies. So that suggests that people who've got the faulty gene, not surprisingly, are getting little cancers that are popping up, then the immune system spots the faulty peptides and knocks them off. But the antibodies are left behind, just like when you get flu, you've still got the antibodies to the flu that help you protect you into the future. So, we're collecting blood samples and sending them to Matthias and his team in Heidelberg at the beginning, after 2 years, after 5 years, because we want to see whether taking aspirin might affect your rate of antibody formation. So the younger team, and some of them here, who take part, obviously we don't expect you to get any cancers, but we would like to see whether we can stop you making antibodies. Because if you don't make antibodies, that means you didn't get any cancers. Make sense? So we've stopped you triggering your immune system, so you didn't even get baby cancers to actually trigger the immune system. So you might say, is that a bad thing? Maybe I need the antibodies. Well, the answer is, the next trial is going to be giving you peptides to make you make antibodies. So what the Heidelberg team have done is made a vaccine made of these peptides. And we're going to inoculate people who carry Lynch syndrome to see if we can make them make antibodies against cancer before they get cancer.
They're reporting on that in June.
Right.
In Sao Paulo.
So the meeting we're going to in June is when the phase 1 started, it worked basically. It makes antibodies.
Yes. And I've recently been diagnosed with an overactive immune system. I'm just wondering, from what you were just saying there, is that anything to do
Is it a
with
good
Lynch
thing?
syndrome?
So I've got an overactive immune system as well. It's a bugger, isn't it? So basically the immune system can be bad for you because it gives you arthritis and inflammatory things and all sorts of things. So we do need to sort of keep it under control. It's like having a standing army that sort of beats people up when it's got nothing else to do. The answer is that probably, it's more, I mean, the immune system is very complicated. I think genetics is complicated, immunology is even worse. But essentially what we probably need to do is modulate the immune system. There are good parts and bad parts. So you might have an overactive immune system, that might be good, it might not be. We don't know, to be honest. My suspicion is it won't necessarily protect you against cancer and Lynch syndrome. It's probably a very specific type of immune response that we need to trigger. So that trial, which we haven't yet got funding for, but there's very great hope for, will be coming down the track. And it doesn't, being in cap3 doesn't stop you getting that. In fact, what we might do is add the vaccine trial onto the aspirin. So people who get a cancer while taking the aspirin, we can try the vaccine on them to see if we can stop them getting more cancers down the line.